But we do have Mr. Brady Haussler starting us off. He's going to be talking about sinusoidal rumble strips, crossover ramp connection design, and ADA curb ramp target values. Brady is a transportation engineer for the design division of the North Dakota DOT, and he serves as the assistant supervisor at DOT. Brady earned a civil engineering degree from NDSU in 2013, and he joined the DOT shortly after that in the Devils Lake District. Brady spent 5 years as a consultant, and then recently in 2019, he rejoined the DOT in the design division. So Brady also serves as an adjunct at NDSU. He's teaching geometric highway design as well as contracts and specs. Mr. Haussler, we're ready when you are.
All right, good afternoon, everybody. Like Aaron said, my name is Brady Haussler, and I'll be providing you today with some of the information regarding the first few topics of today's design updates, which will cover a variety of things. So we were going to first talk about a new type of rumble strips called sinusoidal rumble strips, or mumble strips, as my slide shows there. We'll also cover some changes that are coming very soon to our standard drawings pertaining to ADA curb ramps and the design philosophies we have for those. And then finally, we're going to look at the way that we're going to be potentially changing some of our temporary roadways, the median crossovers, and then the ramp connections that we use on divided highway projects when we have to flip-flop traffic. So first thing here, a quick overview, sinusoidal rumble strips. What are they? Why should we use those? And then how are we going to get those implemented? What is our strategy there? So what are sinusoidal rumble strips? Like the name suggests, type of rumble strip has a wavelength or an undulating pattern there, like you can see in the image, reminiscent of the sine function. So, we already use traditional rumble strips, and everybody is predominantly accustomed to those. They have square or angular edges, and they work. So, question here is, why should we fix something that isn't broken? But other states, a lot of different options have been explored by different states across the country to try to find an alternative to those strip cuts or those angular edges. And it's because they don't just alert the drivers to stay in your lane so that you don't depart your lane, go off a shoulder, or get in a wreck. Side effect of them is that they also produce sound outside the vehicle as well, especially if you're a resident that's living nearby. You probably wouldn't be happy about that. And because of that, the sound can be heard from thousands of feet away. So the thought process behind this new type of rumble strips here is to minimize the amount of sound that's produced interior to exterior. And then there's different design alternatives that are going to impact that. And as I said earlier, there's a lot of different states across the country. They've done a bunch of different studies: Michigan, California, Minnesota, Pennsylvania, and some others. The one that we're going to be looking at here today is our new standard, and it's something very similar to what MnDOT uses and has done quite a few research studies on. And then my last bullet there, a lot of these are commonly referred to as mumble strips just because they're supposed to be quieter. So why should we use them? Why are rumble strips important? Well, we rely pretty heavily on the benefit of rumble strips, and that's because they're a roadway safety feature and we want to use them. But like I said, noise complaints have been around for just as long as rumble strips have been around, and so we don't want that to lead to something to the effect of legislation that might limit their use, because that's a step backwards from really where we want to be. With sinusoidal rumble strips, there's going to be increased noise in the vehicle, which means higher perception by a driver, less likely to depart your lane, like I said. So that way we're maintaining the level of safety that we've already implemented for the traveling public. But then on the flip side of that is outside the vehicle, the noise level is actually reduced. So the new design is just a way of taking something that we already use and that we're familiar with, and then simply finding a way to make it better. So the output of that is just increased safety for drivers and for vehicle occupants and for all of the other vehicles on the road, but also quieter for people living nearby. So a quality of life improvement there too, which really is a win-win. So we get the best of both worlds, and then in the end, we're a little bit closer towards our mission of Vision Zero as well. In terms of where the installation of rumble strips on the center line and the shoulder, where they go, sinusoidal rumbles, we still discontinue them, before right turn lanes or through right turn lanes, 100 feet before tapers. through the radius of an intersection and things like that. So it's essentially identical to the standard variety that we already use in that regard. But some of the biggest differences here are going to be that the sinusoidal type is ground continuously, and you can see the peaks and valleys there on the right side of my slide. They're spaced about 14 inches center to center, which is a little bit further apart, whereas our current standard is 12 inches apart, and they're a series of individual slots rather than that wave-like pattern. Also, as the next slide here shows you, it's pretty similar to our current standard, the sinusoidal design. The width is also a little bit different. It can be modified at the edge line or at the center line, just depending on the width of the shoulder. So the narrower the shoulder, narrower the mumble strips, essentially, is what that comes to. On top, you can see that for 2 foot or 4 foot shoulders, we use a 12-inch mumble strip, and then over on the right there, for shoulders that are less than 2 feet wide, plan on using an 8-inch mumble strip at the edge. With narrow shoulders, then there's a stripe, obviously at the edge line, ends up a little bit closer, or actually in some cases even inside of the rumble strip, but the center line essentially remains unchanged. Finally, implementation strategy. How do we plan to put these things into commission? That strategy is already taking place, actually. So in spring 2020, last year, current design standard that we just talked about, and you can see on the left there, and a pay item on the bottom, were developed so that we could use these in projects in real life. And that as this becomes more commonly used, I have a feeling it'll probably become something to the effect of a standard drawing, the detail that we just discussed. And so you can see there's those pay items I mentioned too. The projects that I mentioned that these have been incorporated into are test projects that the sinusoidal rumble strips have just been change ordered onto last summer all across the state. So as the image shows here, you can hop in the car and see these for yourself. If you take a cruise down Highway 22 over by New England, south of there in the Dickinson district, and Highway 32 in the Fargo district between Lisbon and Gwinner, near Garrison on Highway 37, and 281 north of Carrington in the Devils Lake district. And then there's also Highway 38 in Grand Forks district and Highway 1 in the Valley City district. So there's been a few projects already implemented. They're present in most districts already, not all of them, but they're out there now, so we can see those if you're interested. That wraps up my rumble strip portion of today's design update. Next thing I want to talk about is going to be the ADA ramp design changes that I mentioned. So why is it changing? When will that take place? And then what exactly are we changing there? Keep in mind, what I'm covering here isn't going to be an entire comprehensive list of every change you can expect. That'll be on the new standard, but it's the major things for the most part. So at the bottom of my slide here, the first thing you'll notice is the name of the standard drawing was revised. It used to be called curb ramp details. Now we call that curb ramp retrofit details to better describe the scope of work it reflects. But the standard drawing number is still the same. It'll still be D750-3 for the folks that are out there that have become familiar with the standard drawings. And then why is it changing? So the nature of these ADA ramps is just ever changing. So updates to our standards were necessary just because things like vertical alignment, turning spaces, grade breaks, the widths of the sidewalks and all of those spaces, clear spaces, changes in direction. Those things are all outlined in Chapter 4 of ProAg. Talks about supplementary technical requirements, and there's changes that have occurred there. And as far as definitions and things like that, we needed to update our standard drawing in that regard. Also, I should probably point out too, the new standard drawing was actually approved last week. So all the changes have already been made. So if you want to review it, it's not out there yet, but you can expect to see it here in the near future. It'll be available on the standard drawing page of the design manual. So now we'll look at a few of the changes here that I'm talking about. So there's some changes taking place to the notes. The ones that I have highlighted here are the notes that are changing. Notes 2 and 4, they were revised to include a preferred and also maximum slopes. And a reference was included for landings in note 2 as well. Note 5 was revised to reference a different standard drawing, D750-2. That's because there's a vertical curb detailing adjacent to buildings and other areas shown on that drawing. That was not necessary on this one. And then note 7 is actually completely new. It was added so that we have some description for the general vertical alignment of our ADA ramps there. Overall, some of the terms that we use have just been made more consistent with how ProAg defines them. And then finally, one of the bigger changes too, like I said, is the addition of a target design value, and then also the maximum that we're allowed to design to, that we've become used to seeing on our standard drawing. So the new one is the target value. With the ramp layouts, the old standard, it used to have a right-of-way designation on it from more or less right-of-way at the top. That's been removed on the new standard since there's other contexts that we obviously have to be considering to determine the layout of our ramps and configurations, things like that, not just the amount of right-of-way we have, which in an urban situation gets pretty limited anyways. The curb ramp configurations that you see here on my slide, they're revised to be a little bit more uniform with the notes and the sheet legend. So you'll see that the drawings actually look somewhat simplified, and it's just now that all the descriptions are going to be in the legend. And then there's a reference for turning spaces as well. That's been changed to landing on the layouts, where pedestrians may be required to maybe change direction or things like that between the ramps, based on, again, the definitions and the nomenclature that's in ProAg. That's something we needed to update. The next thing, bigger thing, is the addition of the 4x4 foot minimum clear space found at the bottom of the ADA ramp outside of the traffic lanes. That was added, and it's represented by that dashed box you can see at the bottom of the ramps there. We also have to provide a little bit of tolerance for or variance in the field, and so that's the reason that this target value was developed more of a desirable slope, 1.5% cross slope rather than the 2% maximum, and that's in all directions, defined for landings and turning spaces, like I mentioned a minute ago. And then ramp grades, they have changed similarly. So rather than designed to 8% max, now our preferred running slope is going to be somewhere between 5 and 7.5%. Still 8.3 maximum, but the desirable cross slope there too being 1.5 instead of the maximum 2%. And then finally, at the back and tops of the graphics, you can see on your screen there the transitional tie-in segment, as we call it, the shaded portion, that was changed from the max of 8.3% to just tie into the nearest joint if necessary. And so the location of the transitional area is moved on a few of these layouts, actually, depending on the type of ramp that we're looking at. That changed to include a turning space before the ramp based on some of the guidance that was found in ProAg as well. And then this is the legend, some little things here, but things are all the same. Overall, they look pretty much the same, just a little bit more descript so that we can describe some of those changes in target values and the addition of the clear space, things like that. And then finally, we revised at the bottom of that standard drawing, there's a roadway slope, sections AA and sections BB. We added that 4-foot minimum clear space at the bottom of the ramps that I mentioned on the last slide. And now you can see there that we have dimensions to account for those things and that there's different slopes required in that area outside of the 5% or whatever your intersection grades are. So again, that's outlined by that dashed area at the bottom of the ramps. And so like I said earlier, this is going to be available sometime here in the near future. There's a link to the standard drawings page, and then that will be everything that I have on ADA ramps for today. So the last part that we have to talk about, last but not least, is temporary crossovers and ramp design. So why is this changing? Median crossovers and ramp connections, they get really expensive pretty quickly, especially for something that's temporary. So the thought process here was to look at, try to redesign and reevaluate the way we do these and reduce the cost of using median crossovers and ramp connections on divided highway and interstate projects in the process, hopefully. So each design is a little bit different than the other. For temporary ramp connections here, we have the original design. The tapers are different, the overall length is different, the width and the surfacing could potentially be different too. So the original design has a 50-to-1 taper for entrance ramps, and we use 40-to-1 tapers for the exit ramps. The length is about 1,000 feet for an entrance ramp and 640 feet for an exit ramp, and both ramps are currently 24 feet wide. The new design is going to be a little bit different. It'll be laid out like acceleration and deceleration lanes, which I'll show you here in a second. Here's just a graphical depiction of what a typical temporary entrance ramp looks like that we might use today. Looking at something roughly 1,900 feet in length, using that 50-to-1 taper that I mentioned, so it gets fairly drawn out. And then both of the ramps, entrance and exit ramps, they use 24 feet wide pavement. This next example is a temporary ramp connection with the revised design standards, and we'd be looking at something roughly 1,400 feet long instead of 1,900. It'll be consisting of that 600-foot acceleration lane using an 8-to-1 taper at the end for an entrance ramp, or for an exit ramp, it would be a shorter 340-foot deceleration lane with a 15-to-1 taper. But both ramps in this situation, they both use 16 feet of pavement instead of 24. So it's about 75% of the length, roughly 2/3 of the width, and then just a smaller ramp footprint and less impacts overall. So that's also probably worth mentioning that the current ramp connections that we use are utilizing a paved surface, but based on things like the type of vehicles that are using the ramps or the interchange or that area of the interstate, the volumes of those types of vehicles as well, there could be different cost savings realized in addition, depending on what type of surfacing we used, whether we used paved surfaces or not. And so paved surfaces we'd find on higher ADT roads, larger vehicles, whereas other type of ramp connections, there may be potential for using full depth aggregate instead. And that's obviously reserved for situations where we've got lower traffic volume, lower ADT, smaller vehicles, things like that. But in cases where we would use aggregate, the ramp taper and the acceleration lane, that area, that would actually remain paved all the way to about 150 feet back onto the ramp, while the rest of it is aggregate then. So the reason for the 150 feet behind the acceleration or deceleration lane there, that's just for maintenance purposes, so that we can try to keep the amount of maintenance required near higher volume or higher speed traffic to a minimum. And then finally, the determination of the different type of surfacing that we're going to use for these, that type of ramp connection, that would be based on engineering judgment, but also a little bit of coordination with the personnel over at the district, depending where these are at, since there may be reasons that they may or may not want to go with one surfacing or the other, aggregate or paving. And then median crossovers is a little bit different. Like I said, the original design is based on a couple standard drawings that we have. That's D704, 38, and 39. And the changes that we're going to consider here affect the overall length of them, the different signs that we use, and then how many barriers that we're actually going to require on these as well. So the current design standard looks like this. The design has about an 800-foot crossover length. We use a 40-mile-per-hour warning sign in advance of the work zone to give them warning that the median crossover is 40 miles an hour. And then it requires about 80 barriers roughly. I think it varies between 79 and 85 per set of crossovers, depending on how far apart the center lines of the roadway are there. But the new design is considering a little bit shorter. It's 725 feet overall instead of 800. We'll have a speed limit regulatory sign rather than an advanced warning sign there. It'll be posted for 40 rather than a warning sign for 40. And then we almost use half as many barriers, I think 47 precast barriers with the shorter transitions. So again, it'll be shorter overall crossover length, almost half as many barriers, and then the signing is a little bit different. And finally, none of these are set in stone just yet, and excuse me, none of these are set in stone just yet. Traffic safety section is currently compiling information, and based on what I've just shown you there, to put together a decision document that will later on go to management, and there'll be a commenting period, and then the feedback that we receive from that will base the direction that the DOT will move forward with our temporary crossover and ramp design. So crossover changes, you can expect those types of changes to be coming soon to a DOT near you. That is all that I have for my design update today. My contact information is on the slide if you want to reach out regarding any of the stuff that I talked about today. Otherwise, I think I'll pass the torch back to Aaron.
Sure, Brady. We actually got a couple of questions that came in. Is there any input from motorcycle riders for rumble versus mumble strips and safety?
I'm sorry, can you repeat that for me?
Is there any input from motorcycle riders for rumbles versus mumble strips and safety?
Yeah, actually there is. So the feedback that we've got from motorcycle riders is they do work for motorcycle riders, and so that's actually been looked into. It wasn't just tested for passenger cars, trucks, or heavier vehicles. It was tested for those, but in addition to motorcycles, there was an extensive survey that we did. Or sorry, not we, but Minnesota DOT actually put that together, where motorcycles would ride all the different types of rumble strip design patterns that they were able to come up with, and then they were going to rate how favorable each one of them was. So
Sure.
Out of the ones that worked best for all the other larger types of vehicles that were more frequently used on the highway, the ones that were more favorable out of those were the ones that were implemented for motorcycles. So things like dual rumble strips, where you have 2 consecutive passes of rumble strips running side by side, those weren't necessarily something that motorcycles really liked. And so they looked at a whole bunch of different things, like how they were able to maintain control of the motorcycle, or how they functioned, whether the rumble strips still alerted them on a motorcycle if they were working or not, things like that. So
Sure.
like I said, that study was done by NDDOT, and a bunch of other consultants helped them put that together as well. And
Sure.
there's a lot of good information in there that we could go on for days about. So if you're
Yeah.
interested in, go ahead.
No, go ahead and finish that.
I was just going to say, if people are interested in that, then we can definitely send out a link so they can check out the studies that were done if they have any super technical questions.
Sure. One other question that we got was, will the mumble strips need to be cut again after the first chip seal to remain effective? Our current rumble strips don't need that.
Will they need to be cut again for maintenance reasons?
After a chip seal.
After a chip seal. I guess I'm not positive on that. I have reached out to various folks throughout the district, different districts in the state, and they have, that's something that's come up. I guess they're still pretty new to us yet. And the last winter that we had, wasn't a very trying one for our roadways, I don't think. And so we probably didn't do near as much maintenance as what we've done in the past. So,
Sure.
but it's definitely a concern that's come up when I was speaking with some of the district maintenance staffs across the state. So especially a lot of people who have a lot of experience, they've been doing this for a while. They come up with a lot of things since they're the ones dealing with it on a daily basis. So that's actually where I heard that from. So.
Okay. And then one last question is, the mumble strips, are they still discontinued at 40-mile-an-hour speed zones or near houses like the rumble strips are?
The intent is to minimize the amount of noise that you have. So in urban areas, they may be, obviously, but I guess I would have to refer you back to the standard drawing to answer that question fully here, and I don't have a copy of the new one pulled up since it isn't published yet. So
Sure.
I would have to review that information, but it'll be available here in the near future. So I guess stay tuned.
Okay. Sounds